Welcome students. Exercise 1.2 and the question is 2. Which of the following matrices are transpose of each other? You have to tell the examiner which matrix is transpose of another. If you look at there are four matrices, matrix A, B, C and D, and if you look at here matrix A and you look at matrix B, these two matrices are little bit same. The elements are A1, A2, B1, B2, and here is also A1, A2, B1, B2. But if you can see here, A1, A2 is first row, and in B, A1, A2 is first column. B1, B2 is second row, and in B matrix, it's second column. So A and B are the transpose of each other. If you look at C and D, here, -3, 1, -1 is first row, and -3, 1, -1 is first column in second matrix. 4 to 7 is second row, and 4 to 7 is second column. So here A and B are transpose of each other, and C and D are also transpose of each other. Now what in question number 3? Which of the following matrices are symmetric? Symmetric means same. Okay, whenever you find out the transpose and original matrices are same, then that matrix is a symmetric matrix. If you look at this first matrix A at 5, -7, -1, 5, taking transpose on both sides, this is first step. You have to apply transpose, and when you solve this transpose, first row will convert into first column and second row will convert into second column. So if you see here, in A, -1, sorry, 5 -7 is first row, and in solution 5 -1, -7 is changed with minus. So here transpose of A is not equal to A, so A is not a symmetric matrix. If you consider, or if you look at the next matrix at B, -1, 2, 2, 3, taking transpose, apply transpose, and when we will solve it, this first row will convert into first column and second row will convert into second column. Now if you see original matrix and the solution, -1, 2, 2, 3, -1, 2, 2, 3, these are same. Here B transpose is equal to B, so B is a symmetric matrix. If you look at third part, here we have a matrix C. We will apply transpose on both sides, and when we will solve it, this 3, 4 will convert into first column and 5, 6 will convert into second column. So if now you will see original and solution, 3, 4, 5, 6 and 3, 5, 4, 6, these are not same, so C transpose is not equal to C, so C is not a symmetric matrix. If you look at the next matrix D, and we will apply transpose, and when we will consider, or we will see the original matrix and solution, these are not same, so D is not a symmetric matrix. In next lecture I will talk about question number 4. Thank you.